Hey guys, welcome back. This is Frank, and welcome to our IGCSE Cosi Chemistry revision videos. Our current unit is C6 rates. So, as we talked about in the last video, there are many ways we can measure the rate of a reaction using different experiments and methods. So, in this video, I hope to talk a little bit about the actual theory behind the rate of reaction, and this is called the collision theory, and it is a basis and the fundamental of everything we're going to talk about in this unit. So it's very important, and it's very important that you know it very well. So, without further ado, let's just jump right in. And well, first of all, your first question might be, what even is collision theory? All right. So there are people can give hours of lectures on it, and there are many different videos on YouTube that could help you with that. But simply put, collision theory states that because first, well, you have random collisions that is happening between particles all the time. It's random and it's in any direction, and reaction can only occur if molecules collide with each other. So basically, let's try to give a very uh, vivid example. So let's suppose we have a carbon atom here, and we have an oxygen atom here. I cannot draw a circle today. I do not know why. Perhaps it's big. All right, so this is our very simple carbon monoxide. I'll do it like this so you know which is which. And then we have our happy little very standard oxygen molecule. All right. So this is our carbon monoxide and this is our oxygen. And this oxygen is a bit small, so I'm going to increase it in size. All right. So we have a carbon monoxide molecule and an oxygen molecule. Now, what would happen if these two collided with each other? Well, the first thing might think of is, wait a second, this is going to create some carbon dioxide, right? So this is going to create something like, carbon dioxide, which looks like this, uh, which looks like this. That's our carbon dioxide, and an oxygen atom will be left alone. So it's gonna look something like this. And let me just quickly write it over here: CO2 with just an oxygen on its own. All right. So then does it always happen? Well, of course not. The core of collision theory is that, and I will write it down over here. Um, in a red color. Let's write over here. Reactions only occur upon, and this is very important, upon successful collisions. All right. So what that means is that when these particles collide, because they are in such a random fashion, that the reaction might actually not be successful. In other words, you might have collisions, but just in general, nothing happens. So that is totally feasible. I mean, totally possible, and yeah, if in this example, for example, if we have a carbon monoxide molecule and an oxygen molecule, and we end up with something like this, all right. So maybe the site of collision is like perhaps more like this, and between these two, it kind of just went colliding and whatever, and then you may hear a loud bang, or you might not. Actually, that's a lie. But maybe perhaps we should do some boom, right? So basically, in this case, because our oxygen is pretty chill, and it's just there, so it does not want to do anything because they're not on the same side, right? Like for this one, you need the carbon monoxide molecule to steal an oxygen atom from the oxygen molecule. But then in this case, nothing happens because you have oxygen versus oxygen. Their bonds are quite strong because covalent bonds. So nothing would happen. All right. So in this case, nothing will happen. But then in a case where if we have the same thing. Oh, oops, didn't mean to do that. All right, there we go. So if we have a CO atom that looks like this, and then we have something like this, then what would actually happen is that you have uh, CO, and you have again this O2. I don't know why I keep drawing O2 smaller, perhaps. And then you have some collisions, and then boom. Let's show the same thing over here. What you would end up with is a CO2, is CO2 and oxygen, because this is where the site of collision is, and then this carbon monoxide at a molecule kind of steals the oxygen atom, so now it becomes like this. But if it's like that, then nothing will happen because they're on the wrong side. All right. So this is a very simple, the most simple model of explaining collision theory. So basically, collision theory states that first of all, they move in random directions at all random times, so in a chaotic kind of fashion, and reactions can only occur when particles collide. Alright, so I've cleared things up a bit, so hopefully this would help you understand what is happening here. And this left alone oxygen atom would not be able to survive on its own, of course. If you have two CO, if you have two of everything, then you would have O2 on the side, and then you have something that could feed back into the reaction again, so it would create even more. So anyway, this is the basic idea behind collision theory, and the more and you might ask, like, why this is relevant to our current unit. Well, this is because, as we've said, reactions only occur upon successful collision. This means that rate of your reaction is directly proportional to the number or the frequency of successful collisions you have. All right, so imagine a place where successful collision is only like 10% versus 90%. In this case, of course, you would say that it's more likely for the 90% one to have more successful collisions in the same time. All right, so maybe more collisions per second, and that's exactly the idea of collision theory in the rate in determining the rate of reaction. So the more the particles collide, the more frequent, actually, sorry, that was a bad usage of force. Never write that on your exam, because you should always write more frequent collisions. All right, it's not because of there's more collisions, but more collisions per second, or more frequent collisions. This increases the possibility of successful collisions, because if you have more frequent collisions, it is more likely that you would you have a larger number of successful collisions, and then then reactions, the rate, probability of successful reactions will also raise. So in a word, um, more frequent. So let's say more frequent, or more frequency of collisions, or perhaps you can say more collisions per second. This is very important. Do not miss that. Would increase the probability of successful collisions. So I will have to decrease the size a bit. Or perhaps, actually, you know what? Let's write this on the next slide. All right. So, that's all for our video today. Really, it's a very short video, as I've said, but it is a very core concept. Um, so basically, we talk about some of the most important points in collision theory. First of all, it assumes that particles move in a chaotic and random fashion and collide with each other often. And two, a reaction can only occur when particles collide successfully. And three, reactions are faster when they are more frequent and more and hence more successful collisions. And for collisions to be successful, of course, they must have like sufficient energy and correct orientation as we talk about over here. So we're going to talk about the determinants of the rate of reaction next time, and in that we'll be talking about how collision theory can explain some of the reasons behind it. Hey guys, it's me again. So I just want to make one quick clarification. So I don't think I mentioned that only particles in liquid and gas move in like a chaotic and random way, because apparently particles in solids don't really like to move. So yeah, it's mainly in liquid and gas. And I've also tried to tidy up the notes a bit, so hopefully this one would be more straightforward and clearer. So if you want to take a look, that's you can do it right now. And yeah, that's it for today. And thanks for watching again. And I hope this video helped. I'll see you in the next video. Bye.